This is probably going to be the most technical presentation of crypto line. Hopefully I won't lose too many of you. I'll start out really deep dive technical and then sort of work my way up to higher level stuff. I think this will be most interesting to people that are running Bitcoin or blockchain-based services. But if you're thinking of potentially getting into this space, then hopefully I've got a few lessons that will save you a little bit of trouble. My name is Jameson Lopp. I became fascinated with Bitcoin several years ago. Actually presented at CryptoLand last year about Satoshi, which is a side project that I started that essentially is a fork of Bitcoin Core with a bunch of additional statistics and analytics built into it. I am now employed by BitGo, which is a multi-signature Bitcoin wallet, and we provide mostly a high security Bitcoin security service and both APIs and web wallet. Now, I've been working for BitGo for about 6 months now. It's been a crazy ride, but I am essentially the engineer that's responsible for our blockchain indexing service. And basically, that's a core component of our infrastructure. If you're running any sort of blockchain-based service that needs to track address balances or quickly access arbitrary data from the blockchain, then a customized indexing software solution is going to be critical. I've come to learn that while processing a blockchain on its own is a fairly straightforward task, doing so in a manner that scales better than just linearly as the blockchain grows is quite challenging. And also, once you've mastered processing a static blockchain, processing dynamic blockchains in real time with network activity poses even greater challenges. So the figure on the left should show you a representation of what the blockchain kind of looks like in the real world. So you've got these blocks of confirmed transactions that are being created, but also at any given time you have this sort of nebulous cloud of unconfirmed transactions that's floating around the network, and they're hoping to be included in the block. On the right side, we can see the data structure of what transactions actually look like, which they're actually these chains of inputs and outputs. So when we refer to bitcoins, we're actually talking about transaction outputs that have not yet been spent. Now, due to the ordered nature of blockchains, they have to be processed in order from genesis to the current tip of the blockchain if you want to ensure the integrity of your data. And the naive way to do this is to just request the genesis block from a Bitcoin node and go through all the transactions, iterate through them, and then request the next block, and so on and so on and so on. Once you index the last transaction, you get the next block, and this works, but it scales linearly. You're just going through it one by one. And the blockchain itself, of course, is only growing. We have to keep the entire blockchain from the entire history of Bitcoin in order to preserve the security of the data. So at this time, last I checked, we've got about 80 million transactions that have ever occurred on the Bitcoin network. And trying to process all of those transactions on a single machine, even a powerful server, can potentially take several days, depending on a number of different factors. So unfortunately, blockchain indexing is a difficult problem to parallelize because of all these dependencies between inputs and outputs, and even within transactions within a single block. So it's possible to parallelize them, but you'll find very quickly that your individual transaction workers will quickly get stuck waiting for a dependency somewhere. It's also possible to parallelize processing by allowing these workers to jump further ahead in the blockchain into future blocks, but then if you get stuck, then it can be very difficult to know exactly where you should resume your indexing. I don't really recommend trying to do this. Now, some of the things that I've learned from blockchain indexing are that we've got a couple different problems that come up in the real world. So these are reorganizations, double spends, spending of unconfirmed to unspent outputs, and really long chains of transactions. And then finally, some transactions just never get confirmed, especially if they don't have an appropriate fee. Reorganizations are a major event on the blockchain. Basically, what happens is sometimes miners, two different miners, find a block at almost the same time, and you don't know which one's going to be the main chain. You have to wait for another block to arrive and then go with the longest chain. If that occurs, then you actually have to roll back all the transactions on the orphaned blockchain and then process all the transactions on the new longer chain. And while this only really happens about once per day on the production Bitcoin network, I've seen it happen as much as once per second on the testnet network. And I'll speak a little bit about testnet in a moment. But during some of these block storms that I tweeted about up there, I've seen reorganizations happen that can be as long as 100 blocks. And when these events first started to happen, over half of the public blockchain explorers were actually broken by them, simply because they were not robust enough to handle the unexpected volume of events. Double spins, on the other hand, I mean, that's really Bitcoin's bread and butter trying to guard against. All you really have to do is make sure that you're checking inputs and outputs, that they haven't been used before. Unfortunately, not all the services out here do this, and a few of them have gotten bitten by it. And finally, because some transactions never get confirmed, you'll receive them over the network, but then they'll never get confirmed in a block. So you have to have some cleanup processes that, every hour or every day go back and periodically just revert these from your internal ledger. And if they ever do get confirmed, they'll eventually show up in a block and you can index them again. Now, this is just sort of to try to show you how complex the unspent transaction output set is, which is like the actual Bitcoins. The interconnectedness of all these inputs and outputs really requires that an indexing solution be bulletproof and never fail, because you've got this series of fan in and fan out operations with the transactions and the outputs. And so if you screw up a single one of these little nodes, then you can see how it will very quickly cascade into completely corrupting your current index. Anything that's going to be dependent off of something that you've missed, all of a sudden is no longer valid and will no longer be indexed by your software. And then you're going to have users that are going to be upset because you claim that they don't have any money, or that possibly they have more money than they actually have. As a result, I find that it's crucial to use a reliable database, and highly recommended to use one that supports transactions. Otherwise, if anything goes wrong when you're indexing a transaction, you need to have a bunch of custom logic that will roll back any partial database writes. And of course, if you have partial database writes, then you'll once again end up with a corrupt index. And that will basically result in your entire infrastructure being untrustworthy. And while I'm pleased with the current state of our indexing service, it's become clear to me that scalability issues are looming on the horizon, especially should Bitcoin continue to increase in popularity, and especially if we have an increase in the maximum block size. So I hope to eventually investigate the feasibility of truly parallelizing blockchain indexing by using a method that I'm quite familiar with from some of my previous employers called MapReduce. So I'm basically envisioning that we should be able to take these static blockchain files directly from a node and load them up into a parallelized MapReduce cluster. And doing so would allow you to skip a lot of the tedious work of checking input dependencies, because Bitcoin Core would have already checked those static blockchain files. And I imagine with a sufficiently sized MapReduce cluster, you would actually be able to reduce the initial blockchain indexing time from days or hours to just a matter of minutes. And then once you have that initial build, you'd then be able to fire up your real-time blockchain indexer. So we've talked about unspent outputs and how those are the real Bitcoins from a technical data structure level. There's a lot more to do with the unspent outputs than simply keeping track of them, especially if you're spending them either as a wallet or as any other type of blockchain service. When you create a new transaction, you have a fair amount of flexibility in how you arrange the internal data of the transaction with inputs and outputs. So from a user perspective, all they do is they say, hey, wallet provider, would you send X Bitcoins to address Y? But the wallet, when it receives that request, it needs to comb through all of the user's unspent outputs in order to find enough value to reach the target of X Bitcoins. And unfortunately, there's no straightforward standard way of selecting these unspent outputs. And what we found is there are actually a number of different considerations and trade-offs that come into play here. I mean, the naive approach would be to simply look for the smallest output that's larger than the target amount, take that and spend it. And otherwise, you just start finding the next largest outputs and add them together until you have enough. But we found that this actually results in the fracturing of outputs inside the wallet, such that it will eventually become littered with tons and tons of tiny dust outputs that may not even be spendable on the network. This can be both a performance problem and an irritant to users if they ever try to sweep up all the funds in the wallet and send it somewhere else, because you may very well end up with a transaction that is so huge from a data standpoint and so tiny from a value standpoint that the Bitcoin network will reject it. Now, although a Bitcoin transaction can contain hundreds of inputs and outputs, it comes at a cost, because the more inputs and outputs that you have, the larger the data size, and the fees on the network are actually going to be related to the total data size of your transaction. So if you broadcast a huge transaction, it probably won't even propagate through the network and will never even get confirmed, in which case the only real option you have is to try to open a direct relationship with a Bitcoin miner and try to get them to mine the transaction on its own. And this actually happens. We've seen recently F2 Pool, after recent spam attacks on the network. F2 Pool mined several 1 megabyte transactions, and they did that sort of out of the generosity of their hearts to try to clean up all of these tiny dust outputs. But those transactions would have never been able to propagate through the network. They were sent directly to F2 Pool. So we see all these different trade-offs between privacy, trying to minimize the fees, and then just trying to reduce the total number of unspent outputs that you have to manage in the wallet. It's pretty clear to me that if we're going to optimize this algorithm, we have to decide what our goals are. And your goals will probably vary depending on what your use cases are, what your company is doing. But if you're just a general Bitcoin wallet, I would actually recommend that you pick one of these as a default, but you offer the other types of optimizations as options to your more savvy advanced users. Especially from the privacy standpoint, a number of Bitcoin users who use it because they want to retain privacy would be interested in that, even if it comes at the expense of slightly higher transaction fees. So this is the past year of the unspent transaction output set. You can actually see pretty clearly where some of the spam attacks occurred recently, and the little dips down are like where F2 Pool was trying to clean up the transaction set. It's pretty clear there's no one-size-fits-all to this problem. There's no solution that everyone's going to agree upon. But since the implementations are up to the other wallet engineers out there, I'm just calling on them to try to be good stewards of the blockchain. So we're writing this data to what is essentially a shared resource that's running on thousands of computers around the world. And I figure we might as well try to do so prudently. We've currently got 33 million unspent transaction outputs that require over a gigabyte of data to store in a compact fashion on disk. It's even 3 to 4 times larger than that if you try to hold it in memory to be able to quickly access it. And being thoughtful blockchain engineers, I think, can at least try to prevent the UTXO growth from happening faster than is actually needed. Now, at a little higher level, I think that blockchain engineers should be using testnets. And if you're not using testnets, bad things are going to happen to you in production rather than in test. I mean, this is just general engineering advice, but I've met a number of entities out there who say, oh, we only use mainnet because we figure if you're using real money, you've got a much better incentive to get it right the first time. That's a dangerous proposition. I recommend using testnet because if you can survive on testnet, you should be fine on mainnet. Testnet has a number of different parameters to it that make it easier to attack both from a mining and a civil attack standpoint. And of course, it is preferable that if you screw up and you lose bitcoins, that you're losing testnet bitcoins rather than real bitcoins. We see these events on testnet that I call block storms and reorganization storms. And to be honest, they would probably never happen on mainnet unless something really terrible was happening. But if you can weather those storms, then you should be able to weather stress tests and other attacks on mainnet. Also, sort of outside of the blockchain itself, if you're running a Bitcoin service that's publicly available, you need to have denial of service protections in place. And this is because there are actually blackmail groups that are currently operating out there. One of them is called DD for BTC. And they are actually hitting Bitcoin startups with DDoS attacks and then stopping and then communicating that if their ransom demand for a certain number of Bitcoins is not met, then they will do a full-fledged denial of service attack. You may be able to mitigate this with Cloudflare. A very large number of Bitcoin services use it, but Cloudflare is not a magic bullet. We've actually had a number of issues with Cloudflare affecting the performance of our API. Now, trustlessness is really Bitcoin's bread and butter. It's the primary purpose of the creation of Bitcoin. You should be able to use it without trusting anyone. Yet, we're seeing many Bitcoin users and even businesses throwing this feature completely out the window. Now, I want businesses to understand that the cost of running your own Bitcoin nodes and even indexing infrastructure on top of it is probably trivial in comparison to the value of your business. For example, in the recent BIP66 fork about a month ago, we saw some miners like BTC Nuggets and F2Pool that were running version 2 software and created an invalid block. But then F2Pool, which was actually running version 3 correct software, then mined on top of that invalid block and started creating this chain that was actually invalid. F2Pool then created another block on top of that just because they were lucky enough to find another one. And then, as luck would have it, Antpool, which was also running the correct version 3 software, mined a 4th block on top of F2Pool's 2nd block. This all occurred because F2Pool and Antpool, despite running version 3 BIP66 compatible mining software, were not running full nodes and fully validating the parent blocks that they were building off of before they were commencing mining their own children blocks. So they lost real money. I guess F2Pool lost 50 bitcoins and Antpool lost 25 bitcoins as a result of that. Then just a few weeks ago, we saw a lot of confusion because blockchain.info was reporting that some of Satoshi's original mined coins had been spent. Thankfully, this was quickly shown to be false by people checking their own nodes. And it ended up being a bug in blockchain.info's push transaction API, where they just simply were not validating all of the aspects of the transaction before indexing it within their own infrastructure. So for businesses, it may not be so much of an issue from a resource standpoint to install and maintain a node, but it may be more of an issue with the lack of indexing options that are offered by Bitcoin Core itself. Bitcoin Core only really allows you to index on the transaction hashes, not on all the different attributes within the system and the blockchain. So then you need to run this an out-of-the-box solution such as Insight or Toshi. But if you need more indexing on fields that those don't support, then you might have to roll your own, which is what we've done in BitGo. And this is where it actually becomes expensive in terms of both development resources and operational and maintain resources. Depending upon the query volume and latency needs of your blockchain service, it may not make sense to bother administering Bitcoin D instances and indexing software and all the databases. Using a third-party API will definitely be more efficient. However, third-party blockchain APIs can do more to provide trustless transaction validation. For example, by checking all of the incoming and outgoing transactions against a full node. So if you're using a third party, definitely check to see if there's a service agreement with them and make sure that they are validating with full nodes. If they're just using SPV clients, they will be susceptible to a number of different types of network attacks. Even in environments where a full node is not available, it's possible for you to perform better validation. For example, in our BitGo's web wallet on the client side, our JavaScript does not merely check that a new receiving address for your wallet is a valid address. We actually completely derive it from the master seed to make sure that it is going to be an address that is owned by you and only you. So BitGo is also a member of the Cryptocurrency Security Standard Steering Committee, and we're currently working on figuring out these issues with the certification consortium to try to develop a better standard for how blockchain businesses can validate their data. And it's already quite clear that the highest level of security will require you to run your own nodes, preferably in a trusted environment. User-friendliness is also just a general engineering problem, but in Bitcoin, it can definitely be a challenge. So Bitcoin is this completely new paradigm. It throws a lot of users for a loop. I found that users have been conditioned over the past couple of decades of internet services to expect that central administrators will be able to unlock their account and help them out if they forget their credentials. Of course, any engineer would agree that the average user probably won't RTFM, and they probably won't make secure efforts to keep their data safe on their own. They probably don't even use password managers. So at BitGo, we try to force people to jump through several security hoops by setting up two-factor authentication, by proving that they have downloaded their recovery keys and data. But we can't force them to have the knowledge to continue to use that and to continue to keep that information safe and available. So education, I think, is really the next big step in this ecosystem. In fact, we receive a lot of requests in our support queue for account recovery from people who have lost both their account password and their recovery data that we provide to them when you create a wallet. And in these situations, BitGo is unable to help these people other than by referring them to brute forcing services, which are not guaranteed to work. We are currently working on avenues of developing a couple of different user-friendly options to help mitigate these scenarios, but at the moment, anyone who has created wallets with us so far needs to keep the backups of their keys if they want to recover their wallets after losing passwords. Also, in general, it just seems like users are not at all conditioned to using two-factor authentication. They're not at all exposed to the benefits of using strong password managers and generating strong random passwords. From what I've seen, I think most people still just create passwords in their head and probably reuse passwords all over the place. We need to try to educate users that there are better options out there, both from security and ease of use standpoint. I wish that there was a way for us to force all users to use LastPass or OnePass or one of those great password managers. Also, we've just seen general confusion in people not understanding differences between different Bitcoin services. So we have a lot of people that come to us and sign up for a wallet and then immediately open a support request because they don't know how they can buy Bitcoins within our service. And of course, we do not offer an exchange service. So we are working now on leveraging some of our relationships with different exchanges to help make it easier for people to click through to these other services. But even then, we found that some people seem to expect that once they buy their Bitcoins on a different service that they will immediately show up within the BitGo wallet. Now, back to the Bitcoin network itself, over the past few months, we've experienced dramatically increased transaction volumes due to entities attacking the network. Many transactions have taken longer than usual to confirm because only about 2,000 to 3,000 transactions can be confirmed per block, which is about every 10 minutes. To the end user, this means that important operations like exchange deposits can be delayed for hours or even days. Bitcoin itself offers no guarantees with regard to confirmation times. As a response, at BitGo, we implemented dynamic fee rates within our wallet, and these fees will be below standard during times of low congestion and proportionally ratcheted up during peak congestion periods. We found this to work pretty well so far. Our initial benchmarks estimate the average confirmation time now is only about 2 blocks with our fee estimates. However, we hear a lot about transaction fee markets being created as a result of the new contention for block space. And this is definitely true. It's definitely created more reason for Bitcoin wallets to become better at navigating these transaction fee markets that are becoming more dynamic. However, I found that it's not perfect. The average user cannot be expected to know the current state of the network with regard to transaction volume. Dynamic fees can help mitigate that. However, they cannot predict the future because you're basing these estimates off of trailing data. So there's still a problem where you can create a transaction and broadcast it, and it has the correct